This question comes from Alex, who asks, what if a rogue planet passed directly between Earth and the Sun? At first glance, it seems simple. The planet blocks the Sun. We get darkness, problem solved, but no, it's way more complicated than that. Before we panic, let's define our terms. This has to be a real solar disappearance, not behind a cloud, not a hill, and not some asteroid the size of a basketball. We're talking about a planet-sized body, hundreds of millions of kilometers across, cutting right between Earth and our star, and dragging gravity, radiation, and chaos with it. Rogue planets aren't part of our solar system. They drift through the galaxy in silence, cold, invisible, and alone. Astronomers estimate there could be as many as 100 billion of them in the Milky Way. That's nearly one for every star. But if one of them wandered close enough to line up perfectly with the Sun and Earth, then things get terrifyingly real. Step 1. Darkness. Depending on the rogue planet's size, the eclipse could last minutes or hours. If it's about the size of Jupiter, roughly 140,000 kilometers in diameter, the entire Sun would vanish from view, replaced by a black disk surrounded by a faint solar corona. In the few minutes after the shadow reaches Earth, the temperature could drop by up to 27 degrees Fahrenheit. Within hours, global weather systems begin to break down, solar panels stop producing power, photosynthesis halts, plants begin to starve. Even your cat gets confused, because the day just turned into night and it's not coming back for a while, and this darkness is only the beginning. Step 2. Gravity. Rogue planets are massive. Even a planet with 1% the mass of Jupiter, about 30 times heavier than Earth, passing at the distance of the Moon, 384,000 kilometers, would pull on us with enough force to raise tides hundreds of meters high. Oceans would slosh violently, flooding coastlines. Earthquakes would ripple across continents as tectonic plates flex under the stress. Volcanoes erupt in chains, spewing ash and fire into the darkened sky. Imagine trying to ride a bicycle while the planet itself yanks the ground beneath you. Not fun. Step 3. Chaos. With sunlight blocked and gravity twisting the planet, our climate goes haywire, jet streams collapse. Storms grow uncontrollable. Temperature differences of 50 degrees Celsius or more could form between the darkened and illuminated sides of the atmosphere. Hurricanes, tornadoes, superstorms, floods sweeping across entire countries. And since the sun's heat drives our weather, the longer the eclipse lasts, the stranger the world becomes. Day and night lose meaning, crops fail, ecosystems collapse, humans panic. Civilization begins to crack under forces far beyond our control. Step 4. The aftermath. You might think, just drive west to chase the sun. Sure, if you can move at 1,600 km per hour, which is how fast the Earth's surface spins at the equator. Otherwise, physics wins. Your car loses. Rogue planets aren't science fiction. We've detected a few already, like OGLE 2016 BLG 1928, a world the size of Mars drifting freely through interstellar space, 25,000 light-years away. Billions more drift unseen between the stars. Most never come close to us, but if even one did, just once, it could reshape our orbit, destroy our biosphere, and rewrite the history of life on Earth. And then, eventually, the rogue planet drifts away. The sun returns. Humanity survives. Barely.